Hello friends, my name is Japneet Kaur. In this video tutorial, we are going to create a distance measurer project. The components that we need is one Arduino UNO board, one ultrasonic sensor, one LED, a passive buzzer, and we need two resistors which are of 220 ohms resistance. We need one breadboard and some jumper wires and one wire which will connect your Arduino UNO board to your computer. So let us start with Arduino UNO board. Take one wire and connect the ground pin of the Arduino to breadboard over here. Take the 5-volt pin of the Arduino UNO board and connect it over here. Now, this is our ultrasonic sensor. In this we get 4 pins. First is the VCC, second is the trigger pin, third is the echo pin, fourth is the GND, which means ground pin. So place it over here. So the first pin over here is the VCC. We will connect the VCC pin. These are connected to each other vertically and these are connected to each other horizontally. So take the VCC pin of the ultrasonic sensor and connect it over here, which means the 5-volt, and take the second pin, which is the trigger pin, and connect it to the 10th pin of Arduino. Now take the third pin, which is the echo pin, take this and connect it to the 9th of Arduino. The last pin, which is the ground, take it and connect it to the ground. Now we are done with the buzzer. Now taking up the LED. So in the LED we get 2 terminals. The longer terminal means this one is the anode, or you can say the positive terminal, and this one over here is the negative terminal. This one is the negative, also known as cathode. So we will place it in the Arduino breadboard like this. This is the positive terminal, this is the negative terminal. Placing it over here, and take one 220 ohms resistor and connect it to the positive terminal like this. Now you will take the positive terminal of the LED and connect it to the 7th pin of Arduino UNO board. And the negative pin of LED will go to the negative, means Arduino, or to the ground. Done. Now take the passive buzzer. So in this, the longer terminal is the positive and the shorter terminal is the negative. So I will place it over here like this. Now take the 220 ohms resistor and connect it to the terminal, positive terminal of active buzzer to over here, and take it, and we will connect the buzzer pin to the 8th of Arduino. Now the last pin, which is going to be the negative terminal of our buzzer, we will connect it to the ground pin of Arduino or over here. Now we are done with the connections. Now we are going to write out the code that we will upload in our Arduino UNO board. So let us start. At first, we are going to define the pins. At first, we have constant. This is the constant int trigger pin of ultrasonic sensor, which we have connected to the 10th of Arduino. And in the next, we have echo pin, int echo, which we have connected to the 9th pin of Arduino. Then we were having const and buzzer pin, which was connected to the 8th pin. At last, const int LED equal to 7. It was connected to the 7th pin. Now over here we are going to define one more pin, which is float distance and duration. Float distance, put a semicolon after that, and duration. Remember to put a semicolon after them. After that, we are going to write void setup, which will run only once. And over here, we are going to declare that pin mode LED is going to get output. Pin mode LED to be as output. And next, we are going to have buzzer. Okay, so after buzzer, we are going to take the trigger pin mode. We are going to take trig and write is output. We want the output of that as well. And we are going to take input from the echo pin, right? Pin mode echo to be as input. So now we are done with the void setup. We will now go to the void loop, right? So in void loop, this is the loop which runs again and again. Void loop. Now over here, we are going to write digital write brick pin high, brick pin low, digital write trig pin, which will be low over here. This semicolon after that, and spelling of low should be in capital. Now we are going to write delay microseconds for 2. Delay microseconds for 2. And then we are going to write trig pin high and delay microseconds for 10. I will copy this code over here and I will write it as high. And I will write it for 10 microseconds. Right. Now we are going to write duration. Duration equal to. So duration equal to pulse and echo pin high. So pulse in echo pin will be high. Right. Next, Remember to put a semicolon after each and every line. Now distance equal to distance. This is the formula that it will calculate distance. Distance equal to, we will put a bracket, duration multiplied by 0.0343. Duration multiplied by 0.0343. Right. Now we will close the bracket and divide it with the 2. Put a semicolon after that. Now over here we will write the if condition. If distance is less than or equal to 15 centimeters, you can write any centimeter, you can write 20, 80, it's up to you, that's what you want. So for now I'm writing only 15 centimeters. So what I will do over here is digital write buzzer high. I'm gonna write digital write buzzer to be high, and we want LED also to be high. Before that we will write for delay seconds also. Delay for 1000 seconds. Now we will do same for the LED. I will copy this code and paste it over here. Now over here I will write LED and delay for 1000 seconds only. And if it is if our distance is like 40 centimeters or greater than 15 centimeters, else I will put an else condition for that. If it is greater than it, so I will copy this code again. So our buzzer should be low and LED to be also low, right? So now we will verify it first. You can see the code. Yeah, so it's done compiling. It means that now it's done. Now upload it to your Arduino UNO board. Using this button, you can upload your code to your Arduino UNO board. Now plug into your Arduino UNO board. Now it is plugged in. Upload the code. Now it is done. Now I'm taking something like I'm taking this piece of cardboard, and now we are coming to the 15 centimeters. As we are coming, it is making sound. Now we are at 16 centimeter, it is not making sound, but when we are coming to 15 centimeter, it is making sound. Because in the code we have written if distance is lesser than equal to 15, it will make sound. Means if something is in the distance between 15 and 1 centimeter, it will make sound. It's working fine.